The frequency-severity or frequency-impact model is a statistical framework used in operational and project risk management. This model was not invented by me. It originates in the insurance industry, where it is used to quantify and predict potential losses. It bases risk on two main components. On one hand, frequency. Frequency represents the number of loss events occurring within a defined period, typically a year. Frequency is modeled using discrete probability distributions, such as a Bernoulli, a Poisson, or a binomial distribution. On the other hand, we have severity or impact. This represents the magnitude or size of the loss resulting from each event. This is usually expressed in monetary terms. Severity is modeled using distributions such as a log-normal distribution, a Weibull, an exponential, or a Pareto. The overall loss distribution is obtained by combining the frequency and severity distributions together. This is done through a process called convolution, which we will explain later in more detail. This process sums the losses from individual events to produce the distribution of total or aggregated losses. The steps we need in order to develop a frequency-severity model are the following 4 steps. First of all, we define the frequency. Here, we estimate the number of events using historical data or expert judgment. We select an appropriate frequency distribution to model these events. Number 2, we model severity or impact. We fit a suitable distribution to the magnitude of the losses. This can be done using historical data or by relying on expert judgment, who can define a minimum, a most likely, and a maximum value for the severities or impacts, the monetary ones, of the risk being assessed. Number 3, we simulate the aggregated losses. Monte Carlo simulation is used to combine the frequency and severity distributions through a convolution process. This estimates the distribution of the total losses. Finally, we quantify risk metrics. From the aggregated loss distribution, we calculate risk metrics such as value at risk or conditional value at risk, which inform and support the decision-making process. A practical example. Imagine a construction company that wants to estimate the potential losses from workplace accidents during a large project. So the first step for frequency, the company reviews past projects and determines that on average, 8 workplace accidents occur per year in similar projects. Some projects recorded fewer than 8 accidents, while others had more, but the average is 8. We use a Poisson distribution with a mean, a lambda, of 8 to model the annual number of accidents, assuming these occur randomly and independently. Number 2, we measure severity or impact. The company analyzes past incidents and finds associated costs, medical expenses, project delays, legal liabilities, ranging from $5,000 as a minimum all the way up to $100,000 as a maximum. A log-normal distribution function with a mean of $25,000 and a standard deviation of $15,000 is used to model these costs. Number 3, we perform the Monte Carlo simulation. We generate the aggregated loss distribution by combining frequency and severity. Events are simulated using convolution to determine total loss costs. We will explain convolution later on. For each simulated accident, a cost is drawn from the log-normal severity distribution, and all losses for that year are summed all together. Finally, we perform risk metric analysis. For example, the value at risk, the VAR, is calculated representing the maximum estimated loss with a given confidence level, such as the 95th percentile. This means that there's a 95% certainty that losses will not exceed such an amount. So this is the essence of the frequency-severity model. It is a fundamental tool for understanding and structuring risk models in operational and project risk management. During this course, we will delve deeper into the practical applications of this model.